Hello, Algebra 2. I am going to get you through the next section, which is 7.5. It is actually the last section we're going to do in this particular chapter. So we've done, this chapter is focused on exponentials, exponential growth, and then logarithms. So the last thing that we're going to do in this particular chapter is talk about how do you solve an equation that has a logarithm in it. So when I normally teach this lesson, I go through 4 different types of problems. I am paring that down, and I only want to talk about 2 types that I think will be ones that you could see maybe in a science class and ones that are pretty easy to understand. So I'm going to break them down into type 1 and type 2. When you're done with this video, I'm going to write a Google form. Again, I went on Delta Math and I did not love the questions that were being asked. They were beyond what I was asking you to do or just written differently. So first one, type 1. So the way I would describe type 1 would be any equation that has the same logarithm on both sides. So you're going to see like a log base 3 on this side, a log base 3 on this side, or a common log on this side, a common log on this side. They are by far the easiest logarithm ones to solve. What ends up happening, and this first example is a good example of it, if you have a log base 4 of x plus 13 on one side, and then you have log base 4 of 3x minus 5 on the other side, essentially the logs just cancel. They kind of drop away. And so when that happens, you can put like an x through them if you want, and you are left with just the x plus 13 equals 3x minus 5. And all you do at that point is solve for x like a basic linear equation. So I just kind of showed you my work here to solve that. I subtracted x on both sides to get rid of that x, got 2x, added 5 on this side to get rid of the minus 5, and then divided both sides by 2. Your answer, if you want to check your answer, you can check it very easily by plugging it back into the original, and you should have the exact same log on both sides when you do that. And I'm going to try to work with ones that work out pretty clean. You can get fractions and decimals for these. Those are just fine. You don't get a lot of negatives. You do tend to get mainly positive numbers. Here's another one just to show you one more example. So this is one that is both common logs on both sides. Common logs are logs that don't have a base number. It is an understood base 10. Anytime you see log with no base number, it's base 10. So those logs are the same, so they will cancel on both sides. They drop away, and you're left with 2x minus 8 equals 4x minus 20. And then you go about whatever steps you want to take to solve that. It can usually be done a couple ways. I subtracted 2x on both sides, added 20 on both sides, and then finally divide by 2 to get my answer of 6. And if I want to check and see it's right, I can put the 6 back into the original problem. So that was first type. And very quick, I'm going to have you do a couple on the Google form. Second type are when you have an equations that have one log in it. It can be any log. It can be base 3, base 10. It can be natural log. I'm going to show you a couple of those. They all have the same steps. If you want to take a real quick picture of this screen right here where it has your steps, step 1, step 2, step 3, it'll kind of give you a way to remember what order to do things in, or you can just jot it down on a piece of scrap paper so you know your order. So step 1 is you're going to isolate the log. So you're going to have a log, whatever base, and something next to it. And usually whatever's next to it has a parentheses around it. You want that to be by itself. So you might have to add something to the other side. You might have to subtract or divide. It may already be isolated. Step 2 is you're going to use that, I call it the circular pattern or the cloud pattern, where you're going to rewrite it. And I put a little note over here of what that pattern was. You're going to take the base to this power equaling this value. So you're going to follow that circle. And then your last step is going to be to solve for x. And again, it's going to be something really simple to solve. So I have a few examples here, and then I have a few examples kind of showing you some special cases. So this first one was already isolated. There is nothing on this side of the equal sign that's not part of the log. So you're immediately going to go into that circle pattern. 2 to the 5th power equals 3x minus 1. So we kind of draw these little arrows and write this down. This exponent should be something that you can either figure out in your head, or if you don't know 2 to the 5th power, you can get some big numbers, just grab a calculator. 2 to the 5th power is 32. And then you're left with something that's really easy to solve. So we're going to add 1 to both sides to get 33, and then divide both sides by 3 to get your answer 11. To check this one's a little tougher to check. You can check it with the change of base formula. You can check it depending on what level calculator. You might be able to do this by checking with that. But they are definitely a little more difficult to check than the first type. Second one, so if there's no base written here, I want to show you this. If there's no base written there, it is understood to be base 10. So that means you're going to take 10 to the 2nd power equals 3x plus 1. 10 to the 2nd power, 10 times 10 is 100. And then you're left with something easy to solve. Subtract 1, 100 minus 1 is 99. Divide by 3 to get your answer. Here's one that's not isolated. So this third example has an extra step at the beginning. We have this extra minus 2 that's at the end. That is not part of the log. So to isolate, you're going to add 2 to both sides, and that's going to get rid of that 2. Now you're isolated. You're ready to go to the next step, which is to follow that circular pattern. So 4 to the third power equals 2x plus 6. So 4 to the third power equals 2x plus 6. 4 to the third power, you can grab a calculator if you don't know it. It's 4 times 4 times 4. That is 64. And then you're going to solve for x. So subtract 6 from both sides, you get 58. Divide both sides by 2 to get your answer. I want to show you another one of these, and then I want to show you what happens if it's a natural log. So this is another example of one that was not isolated. So you're going to have to get rid of this plus 7 to start. So to get rid of the plus 7, you're going to subtract 7 on both sides. That gives you a 2. Now it's isolated. So you're going to do 5 to the second power equals 2x plus 1. So 5 to the second power is 25 equals 2x plus 1. Subtract 1 on both sides to move the plus 1. You get 24, and then divide both sides by 2, you get 12. So if it's a natural log, so if instead of being log base 5 or common log, if it's a natural log is written with an ln. It has a base of e. We don't write the e, but it's understood to be there, base e. So if you have a natural log one, I'm going to show you one really simple one and one that has a little more work to finish off here. If you have a natural log and you want to follow that circular pattern, your base is actually an e. So you could put a little e there that might help. So you're going to have e to the fifth power equals x plus 2. So e to the fifth power equals x plus 2. E to the fifth power is not something you can do in your head. So you have a couple answers as far as the way you can write your answer. You do have to subtract 2 on both sides to get x by itself. Your two options are, you can leave your answer as x to the fifth and then a minus 2. That's called an exact answer because you didn't grab a calculator, you didn't have to round. If you want to use a calculator answer, or if the answer is written in a decimal form, the way you do that is you go to second and ln, and that will give you your e button. And then you're going to type in the fifth, hit enter, so then that you know what that is, and then do your minus 2. And that's where this answer of 146.4 is. And I'm going to ask you to round one decimal place, or I may ask you to just leave it in an exact form, which to me is easier and you don't have to grab a calculator. So here's this last one. I'll leave my calculator up to show you the different options for answers at the end. It's not isolated. This natural log has a whole lot of stuff around it. The first thing you have to do to start the isolation process is subtract 4 on both sides. So that's the first thing I did, minus 4 on both sides, you get 6. I have a 3 in front of the natural log. It's currently multiplied. So to isolate, I'm going to divide both sides by 3. So 6 divided by 3 is 2. Now I'm ready to go into step 2. My base is e, even if it's not written, my base is e. So e to the second power equals x minus 1. Add 1 to both sides. So as far as answers, your answers are, you can either leave it in this form. This is called exact form. It's actually kind of easier. You don't have to worry about having a calculator or rounding. Or you can grab a calculator. You can hit second ln to get your e button, squared. If you want, you can just go down, get out of the exponent, and then hit plus 1. And that's how you get a rounded or an approximate answer. And I rounded just to one place, 8.4. So those are the two types you're going to be asked to do. Your first type is very quick, very short, just kind of those logs just cancel, just disappear. And your second type takes a couple steps. Again, you want to make sure you have those steps written down. Now, again, to make sure that people are watching this video, I'm going to have a question on the Google form, and the question is going to ask what my number was in college on my softball jersey. And the answer to that is I was number 3. So when you get to that question, if you've watched this part in the video, number 3. All right, guys, I will talk to you soon. Miss you. If you have any questions, reach out. If you need to ask more clarification, send me an email, send me a message, and we can talk. Other than that, this should be pretty comfortable, hopefully, for you, and you can get that assignment done. See ya.